Okay, good afternoon. We're ready to start. Speed it up and spark it up at Intel. So first I'm going to do a little introduction about myself. And I joined Intel after graduation and been working in IT, supporting big data capability since then. And just to tell you a little more about what we're doing at Intel, in our team we have two groups, and one is system engineering. They support and maintain our Hadoop clusters on-premise and on cloud instance. They also support enterprise security, and they ensure all our environments are fully secure. Our Hadoop clusters are kerberized with Sentry enabled and integrated with LDAP and Active Directory authentication, and we also have encryption. We also support encryption. The other group is capability engineering, and we are part of that group. We provide support on the application side. We facilitate to Intel Business Group to we facilitating guidance to allow them to develop and deploy their applications faster by taking advantage of the latest big data ecosystem tools. And just to recap about myself, this is how people that know me thinks of me at work. In reality, this is how I feel. But the truth is, I really love and enjoy troubleshooting. I have fun looking at logs and trying to find the root cause of the issues and ways to improve it. And I will share of my troubleshooting experience later after Snehal. So.
Thank you, Sandra. About Snehal, I'm working with Intel, same as Sandra, with the Hadoop technology. I'm 3+ years of experience right now. I'm also part of capability engineering group at IT Intel Corporation. I have done Master of Science in Computer Science from Sacramento. In the first year working at Intel, I had a publication with my Intel team folks. The publication was on power efficient MapReduce workload acceleration using integrated GPU. Other than work, I like Zumba and Latin songs. This is my bitmap. Looks closely like me. This one is particularly from India Independence Day. Our objective is to share the experience and key learnings from the journey of data ingestion framework using Spark. We're going to explain you how to speed up application development using Reusable Ingestion Framework and how to improve job performances. Speed it up. We really want big data application to be out of the door quickly as soon as possible, kind of a deal. The very first step for developing any big data application is to bring data to Hadoop, and it could be challenging. We're going to help Reusable Framework to do rapid data ingestion. We have variety of data sources to bring data from, such as RDBMS, spreadsheets, or social media logs, Salesforce, things like that. We encourage our solution to be reusable so as to minimize efforts of duplication within the organization. These things, big data ecosystem is growing very fast, and that's why keeping up to date with the tools could be a challenge. We want to increase developers' productivity at the end of the day. So reusable framework with Spark. We know Spark is an industry standard these days. Within Intel, Spark is used across all the organizations for Hive query or for data scientists to make prediction models. So Spark has proved its own importance across the industry. Spark at the same time supports uniform data access using Spark SQL. And thus, the Spark SQL is the core of ingestion framework we're going to introduce shortly. So those who are still coming, oops. Yeah, we can play the video if you liked it really next time. So to brief you about the BDRF or what was covered in the video, there is a guy from supply chain wants to bring data to HDFS. He doesn't know necessary tools for it, so it's going to take a month to just bring data to Hadoop, and then he can provide his analysis to the organization. So how we can help him? Being at IT, we see the similar requirements coming from other organizations like sales and marketing, HR. So we decided to bring a common reusable framework for all those who need to bring data into Hadoop. So if you look at the code snippet here, it's a Spark SQL ingestion. And within single line of code, we are able to bring data to data frame. What we are doing here really is using SQL context, using load method, and providing necessary options, such as JDBC URL, table name, or a query where you want, or a query based on the table, and the driver. So in these three examples, JDBC extract, Google Analytics extract, or SFTP extract, apart from few differences, it looks the same, right? Also, using this framework, we provide seamless job deployment. Using Spark mode as one of the parameter in configuration file, user can just switch between the available Spark modes. We use, by the way, we are using Yarn as a resource manager here. So we can switch between local mode, Yarn client mode, or cluster mode. Similarly, how do we manage dependencies in Yarn cluster mode? Here is the code snippet. Sorry, I meant to point. Here is the code snippet where we are doing all the jars necessary. We are distributing it across cluster. We are asking them to give necessary memory required for the job to run and necessary parameters for a Python file. So we have put a framework utilization dashboard just to show, like, let's say for example, SFTP component is being consumed by X number of projects. So that shows how the reusability can save time instead of duplicating the efforts. Sandra can go into details of Spark tuning. Sorry.
Okay. Before I start, I would like to ask a few questions so I can know about this audience. So how many of you, you can raise your hand, already have your application, Spark application running in production? Okay, good. And how many of you have Spark enabled to run your jobs in cluster mode? Okay. And my last question is, if you guys are using Python, PySpark to develop your applications. Okay. So at Intel IT, we have Spark on Yarn enabled, and we wanted to share the challenge that our Intel business group have reported to us, either by using their own code or using that reusable framework for ingestion that Snehal just covered. And we will not focus into the Spark internals. We just want to share recommendations and considerations for the PySpark developers or on how they can improve their job. At Intel, we wanted to share how we spark it up to get better resource utilization in our Hadoop cluster. So the first scenario we're going to see is parallelism. So in a distributed environment, the goal that we're looking to achieve is how we can optimize or maximize the parallel processing. And we know that in Spark, the number of threads are determined by the partitions on an RDD. And here are some methods maybe you already are familiar with, that we can define the number of tasks or threads for Spark, and one of them is to use a number of executors. We can pass that in the configuration parameters. Also, we can use transformations like reduce by key, where we combine the same key on the single machine, and this is recommended for large data sets instead of using group by, to reduce that amount of data that go into the network. And then we can also use repartition to increase the number of partitions, or coalesce function to reduce the number of partitions as well. And there are these other two properties that you can set up at the environment level. The shuffle partition, it will work for a Spark SQL, and you can also use repartition in this case. And the default parallelism, which is recommended to use the 2 times the number of cores for the jar containers that has available. So all these methods we already know, and to make our job to run in a parallel fashion. But we have some scenarios, and here it's one. In this case, we can now achieve parallelism. When we do JDBC ingestion, the JDBC driver will only define one partition, and by then it will be only one executor running the whole job, doing the whole ingestion. So how we can overcome this? In the JDBC connection string, we can also pass the partitioning column name. We can specify the lower bound and upper bound, as well as the number of partitions. This bound has to be integers, and they will define the partition stride. So we already overcome that single executor, and we know that we can define different partitions. But what happens when the data that we ingesting is skewed, when we are facing skewed data? So we managed to create 10 partitions, and we have there 10 executors running. But as we see, only 2 of those executors are taking all the load. So how we overcome this? We can take back out of our data source and try to find another column that represent better the data distribution. But what happens if there is no one there? So we can also use a tuning this number of partitions. We can increase, and we're going here from 10 to 1,000 partitions, and also we can tune in the number of executors. And we're going to see that in the next slide. So here I'm going to do a performance comparison on the ingesting over 4 million records. So as we see, this is the first case when we use as default 1 executor and 1 partition. This will take us over 18 minutes. But now, if we increase the number of executors to 5 and 1,000 of partitions, we are able to process this 2 times faster. And let's see what happens when we do with 10 executors instead. Yeah, it's going to reduce to 8 minutes, but we don't get too much performance there. And this is because we are creating overhead and delay in the executors. But if we tune back again the number of partitions to 500 instead, we can almost get 4 times faster as a single executor as a default. So just keep in mind to tune up the number of executors and partitions when you're doing JDBC ingestion. And here is another comparison, and this is mainly because we working with big data, and sometimes we overlook the number of columns. So here we have a table with over 11 million records with 121 columns, and sometimes we just wanted to bring the whole table, but we don't see that if we reduce the number of columns, we can get some improvement on the processing time. And as we are familiar with the 80-20 rule, or the Pareto principle, where in most of the cases only the 20% is what we really use. So here we can see a good increase in performance if we only select or filter out that columns that we needed. And okay, so then this is the second challenge that we face when we're dealing with big data sets, and we get some failures on our job, and we're trying to process a table that is over 2 terabytes of data, about 6 billion records. And when we run this job, and here what we're trying to do is we have a Hive table with this big size, and we are loading into a data frame, and they want to do a lot of aggregations and transformations, and finally we're going to call an action to count. So as we see, Spark is going to launch around over 25,000 tasks, and it's been already 35 minutes, and only 53 of these tasks has been completed. So as we see, eventually what the user is going to get, it's a heap space error, and finally it's going to get the termination signal by Yarn. So how we can, what we can do to deal with this in this scenario? If we look into more details on the Spark logs, we can see on the stages that we have only processed 3 gigabytes of data, complete around 800 tasks, and the input size record, it's the maximum, each task is processing around 120 megabytes of data. So when the job stages have to deal with input side, we need to be careful about the memory that we assign to each executor, and also the cores that we assign, because the memory will be split between these cores, and this will be the memory available for each task. So what we can do is, there is a post by Cloudera where is this formula to calculate the memory available per task. So we can use this formula to experiment and see what could be the ideal memory for the executor, as well the number of cores. And the shuffle memory fraction and the safety fractions, those are default. So we can see here that we can start experimenting with 8 gigabytes of memory, the defaults, and 6 cores. So with this, the memory available per task is 218 megabytes. So we can try, give it a first try, and see if we are able to complete, to run this query. If that's the case, we can also keep tuning up and instead do 6 gigabytes and 4 cores instead. And we can see that we get more memory allocated to each task. So again, this will be a better solution, and it's good to have this formula when we're facing big data sets, when we're facing issues with big data sets. The next scenario is deploy dependency on cluster. So, and this is more for Python lovers. When one of the disadvantage of Python is that Python is not a JVM language. So that means that Python depends on the platform, and the developers cannot just jar their code and pack their code and deploy. And also, when we're working with a Spark API on a distributed environment, we need to be able, we need to make sure that all the executors have access to the Python and also the libraries. So how we can deploy our code across the cluster. So here are the steps, and we have deployed Anaconda parcel in our environments. And with that, we can use the Conda package to create our Conda environment, install our custom libraries. We zip this environment, we load it into HDFS. So in this way, all the executors will have access. And then we pass the Python environment parameters or variables to tell Spark which Python needs to be used when running that job. And here we can see in more detail, and a recommendation is to create an environment directory, because if no, it will, the content environment will create it under the user home directory. And here we are creating an environment with Python version 3.5. We install this library, Fuzzy, and then we zip this library, we create a soft link, we load the zip file into HDFS, and we provide the driver, the Python driver variable, and we tell Spark which Python version to use, which is pointing to our content environment. And then in using archive, we tell where is the location of this zip file. And here is a comparison, and this is a job running using Fuzzy. Fuzzy use Levingston distance to calculate that the difference between sequence. And one of the modules on this library is fuzz, and it's used to compare it, to do a string comparison. And it's used in this code to compare Intel internal manufacturers' names against external vendors. When we run this code in the local mode, the processing time will take like over 40 minutes. But as we are able to deploy it in a cluster mode, we get a performance over 6 times. The next is optimization, and we can use this when we working with joins, especially when we have a large table like a fact table against a small table as a dimensional table. We can use the auto broadcast threshold parameter. We gave a value to enable, or we define as a -1 to disable. And we can use the explain command to see the execution plan. So here we can see how we enable the auto broadcast join threshold. And what it does is gonna take the small table and it's gonna broadcast it into all the executors. And how it does is first it fetches it to the driver, and the driver will send to all the executors and then load it into memory. So here we have when it's disabled, and we can see in the execution plan that the broadcast join is there. If it's not, if it's disabled or set up as a default, it will be a sort merge join. And as we know, this is a very slow process. So here is another comparison, and we have again a big table over 2 terabytes of data, again a small table, only 300 kilobytes. And if we run it as with the default settings, and it will be 14 minutes, but we get an improvement by using the auto broadcast threshold, and it's going to be a performance increase of 1.6. So lastly, using caching data frames, and mainly use in machine learning as we loading and doing several transformations, or also doing some joins. Sometimes we want to go back and take the initial data frame, or going back to one of the previous ones. So instead of reprocessing, we just cache this data frame, and it will load it we save it into memory. So this is, and just to summarize, you can run your Spark job, check the logs, find what are the bottlenecks, and just spark it up, and follow these recommendations to spark it up, and that's it. So questions? Sure.
In one of the slides, you said reducing the number of columns from 120 to 30 improve the performance. Can you explain that? Because I don't understand why.
Because like I mentioned, because it's big data, we assume that, okay, we can bring the whole data, but we don't see, we overlook the processing time. So sometimes you only use for query purposes, or you only use a portion of these columns. So you could filter out the columns, and with that it will be less data that you are ingesting. So
only the size of the data?
yes, yes, yes. Any other question? Yes? No, no, no. I think this was on the join, no?
Yeah.
Yes. Sorry. Okay, at 1.6. No, no, no. It's when you do the join. The auto broadcast threshold is used for improvement on the join. You need to have a small table, and the small table will be the one that will be broadcasted to all the executors. And with that, you gain performance.
Yes, question.
So, continuing on that, is that value in bytes?
Yes,
And I'm guessing that depends upon the data that you're working with to come up with that.
correct, correct. So sometimes you can set it up, and when you go and see explain, it's not showing. So you need to, change it or increase that bytes that you are passing.
How did you come up with the number? Was there a particular approach to sizing on that? Or just trying and see?
Yes, trying and see. Like the default is 10 megabytes, so you can start with that. Yes. Mm-hmm.
So does that fuzzy runs in a distributed mode when we archive it?
Yes, when you deploy, when you create your content environment and zip it, yes.
Can we do the same in Spark R? Are you aware of it? Like R libraries? Can we make it distributed?
I haven't worked on that. Yeah, I could check. Yes.
Yeah, just curious to know what's the biggest join you have in hotels. You have the join, right? You do the performance, the broadcast, the smaller tables. But just curious to know what is the biggest join you have now.
So what is the biggest joint we faced? Like what was our customer using? Like any number on top of your head?
No, I guess on the terabytes of
Yeah.
data, yes. Any other question? Yes.
So we run into some issues with shuffle fetch failures, primarily income versus shuffle. We tried playing around, increasing the number of partitions that we can get the shuffle sizes down. Is that something that you encountered or
So you're increasing the number of partitions with repartition? Yeah, but keep in mind that when you're using repartition, it will shuffle the data. So that's
Yeah, so it's we have failures where the actual fetch is failing, either because it's not compressed properly or potentially an empty shuffle file, and so it just ends up failing out.
and what is the error like?
You get a handful of different errors, but fetch failure exceptions. There's something about the byte sizes.
And did you check like also in another slide I mentioned about the memory that is assigned to each task, like because I'm to see how much data each task is.
Yeah, it's not getting any out of memory errors.
Okay, if the fetch is
Fetching the shuffle files.
okay. Yeah. Okay.
Okay. So if not any other question, I'd like to conclude.
Thank you.
Thank you for showing up. Thanks.